All right, algebra 2, here is our part 2 of this completing the square business, okay? So we talked about some steps above that'll help us to rewrite something as a perfect square trinomial, a quadratic expression that is missing the last term, or maybe it doesn't have the right last term, right? It doesn't have to necessarily be missing it, but maybe the last term isn't the number we want. Like in part B, you might already notice, oh, I figured out that y squared minus 12y in order to have that be a perfect square trinomial, we need to have plus 36 after it. But the issue is that it's 4. So we're going to have to fix that a little bit. Let's go ahead and talk about how we can fix that using this process completing the square. I'm going to abbreviate it as CTS in case you ever see that. Okay, CTS. I almost stopped sharing. Sorry about that. That's why I paused. I almost accidentally clicked the stop share button. CTS, completing the square, can help us solve some quadratic equations that can't be factored. For example, notice B. We're going to start with B, and then I'll show you why A is a non-example of where we don't necessarily need to use completing the square. Looking at B, can I factor this? Are there factors of 4 that add up to negative 12? Well, no, because 4, it's only 1 and 4, and 2 and 2. None of these are going to give us negative 12. So I can't factor this, which means I need a new method. This is where completing the square is going to help us. So let's talk about steps, okay? And you're gonna wanna write these down as I go, because when we do part A, I'm gonna erase them, all right? So step 1, we're gonna go ahead and separate C from ax squared plus bx. So take the constant term and push it away from the ax squared plus bx part. Okay, so what does that look like when we do that? We end up with y squared minus 12y, and I'm going to put it in parentheses and leave some space for that missing term, plus 4 equals 0. Okay, so all I did was shove the 4 to the side a little bit. I don't want to talk to the 4 right now. Okay, I need the 4 to mind its business for a quick second while I complete the square, while I deal with my friend's drama over here with my y squared minus 12y. They got some drama that I got to help them out with. And their drama is figuring out what is missing in their life. What is missing that will complete their life, in this case, complete their square, okay? So you already kind of know what number this is. It's 36 from above, but let's kind of recap how to find that. That's actually step 2. Now, step 2 actually is not what I just said. Step 2 instead is factor out GCF from ax squared plus bx if possible. In this case, it's not possible because this is a 1 and this is a negative 12. So we don't really care about that. That's why I accidentally skipped it, because we don't have to do it here. But you always want to make sure that's step 2, because sometimes there will be. Now here's where I was going to say what step 2 was. This is step 3. Calculate b over 2 squared. Okay, what's b over 2 squared? It's going to be negative 12 divided by 2 squared. That's negative 6 squared, which is 36. And so 36 is going to go here. But now what we need to do is balance. We need to find the balance in our lives. Okay, balance. And I guess actually I should add to this step here. And add to ax squared plus bx. Okay, because that's what we did. We added it to our ax squared plus bx. Now we got to balance the equation. Okay, I can't just willy-nilly add this 36 here, especially when it's an equation. I got to balance that by somewhere outside of my parentheses, subtracting 36. Because when I add and subtract the same number on both sides of the equation, that's how I can balance it. Because plus something minus that same something, is 0, right? If I add 36 but then subtract it right out, then it's like I did nothing, right? But only what I'm going to do is add on the inside, subtract on the outside, okay? So I end up with y squared minus 12y plus 36 plus 4 minus 36 equals 0. And we know 4 minus 36 is negative 32. So this is y squared minus 12y plus 36 equals minus 32 equals 0. Okay, so you add it, always add in here to our ax squared plus bx, in this case our ay squared plus by, add it to that, and then subtract outside of the parentheses. All right, add on the inside, subtract on the outside. And then our step 5 is factor the perfect square trinomial, PST. This is our perfect square trinomial. That's going to factor to y minus 6 squared, right? Remember, we saw a direct correlation. It's always half of the middle term. Negative 6 is half of negative 12. Minus 32 is equal to 0. And then the last step is to solve. Okay, let's solve this. This looks like something from 4.5. Let's get this squared thing by itself. So add 32 to both sides. And we get y minus 6 squared is equal to 32. Square root both sides. Plus minus, don't forget your plus minus, right? We get y minus 6 is equal to plus minus square root of 32. Let's see if we can simplify 32. Is there any perfect squares that go into 32? Well, there's 4, but if we try a little higher, there's also 16. I can rewrite this as plus minus square root of 16 times 2. And this is going to become 4 square root of 2. Y minus 6 is still on the left. All I have to do to finish is add 6 to both sides. So I get y is equal to, sorry, I'm kind of cutting out down here. Y is equal to 6 plus or minus 4 rad 2. Okay, and then I didn't go over this too much in that square root chapter, but remember, this is two different solutions. One answer is 6 plus 4 rad 2, and the other answer is 6 minus 4 rad 2. This is just a shorthand way of writing it. Okay, hopefully those steps make sense here. Let's go ahead and go back up and see why part A doesn't really fit this. Notice the left-hand side. It's already a perfect square trinomial, right? Because I can factor that as x minus 1 squared equals 144, right? There's only one factor of 1, it's itself 1. And since this is positive, it's got to be the same sign. So those two 1s are either both positive or both negative. And since they're going to add up to negative 2, they both got to be negative. So it becomes x minus 1 times x minus 1, but then it's x minus 1 squared. Here, I don't have to complete the square. I'm already good. This already looks like this right here. And all I had to do here was square root. So on both sides, I'm going to square root. Plus minus. X minus 1 equals square root of 144. We know that to be 12. Okay, so x is equal to, all I got to do is add 1 to both sides. I get x is equal to 1 plus or minus 12. Now, since we know how to add and subtract 12, let's actually do this. We don't have to leave it in that form down there. So 1 plus 12, that's going to be 13. 1 minus 12, that's going to be negative 11. So we know our answers are negative 11 and 13. I don't want you to leave it in this form whenever you actually can calculate it. Here we could calculate it, so we want it to be nice and simplified. Okay. Join me in the next video to see how we can do part C using these steps.